Hello everyone. So in this video, let us talk about the first three problems from the latest Leetcode Biweekly Contest 70. So let's start. The first problem is minimum cost of buying candies with discount. So you can read the problem statement. I'll tell you in simple terms. It states that you are in a candy shop and you're selling candies such that for every two candies that are sold, the shop will give a third candy for free. Now you can buy these candies in any order, but there's a condition in which this property will hold. That is, the customer can choose any candy to take away for free as long as the cost of the chosen candy is less than or equal to the minimum cost of the two bought candies. So let's say that the customer bought a candy of, let's say, 100 and 200. So now the customer can only get a candy for free which is less than or equal to 100. So because as you have seen that you have gone for buying different items from different malls, so you cannot just buy a item for 100 and 200 rupees and get a 5000 rupees watch free. So you can only get an item free that is less than or equal to the minimum of both the two items that you have bought. Okay, that's the whole condition. Now what is the minimum cost that you have to give to buy all the candies that is given to you? That is the whole problem. Now what you can observe here is that the first condition which I thought to is, let's say that there are two candies only. So for that case you have to buy the two candies because there are no three candies. Also in the array also, let's say that I have 5 candies. So for any 3 candies I can do this trade-off that I will buy 2 candies and get 1 candy free. But for the other 2 I have to pay the whole price. I hope you get the point. So what you have to now do is, because I can buy out 2 candies and get the third minimum candy free. So it means that I have to somehow sort out the whole array. So you can easily first sort out this whole array. So if I take this example, then it will become more clear. 6, 5, 7, 9, 2. 6, 5, 7, 9, 2 and 2. Now first sort it out this whole array. So it will become like this: 2, 2, 5, 6, 7, 9. Now in this there are pairs of 3, 3. That is fine, but let's assume that you can take out this example. Now how will you first solve this example part? The best part is to, what you can see here is that, let's say that if you take out 2 elements, then you get the minimum of, so let's say if you take the 3 elements, let's say, then you have to pay for the 2 larger one, and the third one, the smaller one, you will get it for free. Similarly, you can buy these 2 and get this one free. So it actually just means that you have to do a for loop, get the first 3 one, like get the 3. I just jump for 3, 3. Okay, so if you take the first one, then go I plus equal to 3, and for all those 3, what you guys just have to check that you have to buy the 2 larger one and get the smaller one free. So you just have to add the total price of the 2 larger one of these 3 triplets that you're talking about, and then you can get the value. And if the total triplet is not there, let's say the total array like this 2, 2, 5, 6, so you get the triplet for the first one, and then because there is no triplet, you have to pay for all other 2s if there or other one which is available there. That's the whole logic, but there is one catch out there. I erased it out. So I also get messed up when I was thinking about this point. So what you can see here is, let's say that the array is like this. After sorting it out, it will become like this. Okay, let's erase this out. So what you can see is, let's say the array is like this: 2, 2, 5, 7. Now if you form this as a triplet, okay, so you not take the minimum one of these 2, you have to pay for these 2, that is 2 plus 5, and then the last one you have to also pay to get that, so it is 7. This is one of the way. But if you take it from back, so you're taking the you're taking or making a triplet from from the start, the first triplet, second triplet, and so on. And if there's no triplet, you will take the whole numbers that is in this value and you stop. But instead of that, start taking from the bottom. Actually take this and this triplet. Why? Because in this case, let's say that you have to buy only for the top 2 largest one, and then you get the third one free, and then you will buy the one that is a smaller one. So in this case, what you can see here is, okay, it will actually turns out to be same in this case, but let's say now let us take that this is 3. Actually that will become more clear. So you will buy for 3 and 5. So 3 and 5 you'll buy, you'll get 2 and free, and for that you get 7. In this case, what you can see here is that you will buy 5 and 7, and you'll get 3 free, and you have to pay for 2, and this one is smaller. I hope you get the point. That's the whole logic. Why you have to move from bottom, not like from the right to left, not from left to right, because In this case, the one that is not completely filled, like the triplet that is not completely filled, will be the smaller ones. And because you have to just take the last triplet that is not completely filled totally, because there is no complete total fill, you have to take all the elements to buy all the candies. It is beneficial to take the one that is smaller one, okay, and leave the one that is larger one. Like you have to take this. So better move from the right to left. That's the whole two things you have to keep in mind. So what you can see here is that this is the total cost. You have to first sort it out. Start from end to start, or you can have sorted this in a decreasing order also, and done from left to right, whatever you want. Okay, I've just sorted it in like increasing order, and then move from bottom to top. As you can see, I'm jumping by 3 space. If there is a triplet of length 3, what I have done here is that -2, which means that there's a size of 3, like triplet size array that is possible. Then what I've done is I have taken the cost for the current element and the previous element, like the previous to that. Else, if there is no triplet that is possible, then it is possible that maybe there are 2 elements. For 2 elements, I just have to add both the elements, because I have to take both of the elements. If it is not possible, there is only maybe 1 element present. Take that element, and you will just stop at this point of time. I hope you get the point. So you have to just keep in mind that whether a triplet is possible, because you should not be taking any index that is out of bound. And that's the whole logic for this problem. All the code will be in the description of this video, so don't worry, you will be like having those codes out. The second problem is count the hidden sequence. Well, count the hidden sequence is a good question. You just have to take some mathematical logic around it, but I'll tell you in simple terms. It states that you are given a 0 indexed array of n integers differences. So you are given a difference array which describes the difference between each pair of consecutive integers, so of a hidden sequence. So there's a hidden sequence, and if you subtract out the consecutive differences of those hidden sequence, such that you have to do the subtraction of a hidden +1 and hidden I. So I plus 1 and I. So I plus 1 and I plus 1 and I, you have to just find out the differences, and that's the difference array you have. Now, what you are actually given here is that from this difference array, you have to find out the actual array. But there can be multiple actual arrays, because if you start from any number, let's say that you start from 5, then you can build one array. You can start from 6, you build that array. I'll tell you when you draw it out. But that is one of the options. So there's also given that a lower and upper bound to the numbers that can be used in the array. So there's also given that the numbers in the array can only be between this lower bound and upper bound. Okay. Now you just have to tell that how many possible sequences are there if like the lower bound and upper bound is given to you and the difference array is given to you. That's the overall problem. Now you can pause this video. We'll move down to a drawing board to even make it more clear. If you take this one, that is 1 minus 3 4, lower is 1, 6 is upper. Cool. 1 minus 3 4. 1 minus 3 4, and lower is 1 and upper is 6. Cool. Now how you can do that? Now what you can directly observe is that what I've told you, that there can be multiple sequences. Why? So let's say that the first number is 1, because you are finding out the differences of I number and I plus 1 number, so like I plus 1 and I, so which means that the second number will be this number plus the difference. So this is a difference array, difference between this number and the next number. So if this number subtract this number is 1, you just add this number to this number and you will get the next number, that is 2, because see 2 minus 1 is equal to 1, so that's the difference array. So you just take 2. Now what you can see is that is this 2, so the next number is this plus this. So as you can see 2 minus 3, so 2 minus 3, that is equal to minus 2 minus 3, that is minus 1, then 4 plus minus 1, that is equal to 3, and that is the actual array. If you take like let's say 1 as a starting number, then this is one of the hidden arrays that is possible. But this is actually not the array we're looking for. Why? Because this is the lower one and upper that is given to you, that all the numbers in this whole array should be between this lower and upper, that is 1 and 6. Now there's a number that is -1 that is smaller than lower, so that is not possible. I hope you get the point. So how you can find it out? So what you can easily do is let's say just generalize it. Okay, why generalizing I means that let's say that I start with a number a. Okay, if I have a number that is a, that is the first number, what is the next number? So if you take this whole array, like this is the same difference, so a plus 1, because the next number will be this number plus the first number, so a plus 1. The next number will be this number minus is a minus 2, then you just add this, so a plus 2. Okay, so I think so that is the correct thing, that a plus 1, then a minus 2 add kar diya, so then it will become -2, and then you said cool. So these are the numbers. So this is a generalized form of the sequence. If you changed A, because A is a starting number, if you change A, then the sequence will be starting here. Now you have to see that. Can you tell me what is the minimum term of this whole sequence? Can you tell me that? You can directly see that the first term is all like the first value in this whole terms is same, like A. So the number that is so minus 2 is decreasing A by 2, and so and plus 2 is increasing by 2, and this plus 1 is increasing by 1. So what will lead down to the smallest among all of them? Obviously this term. Why? Because A is subtracted by 2. I hope you get the point. So it means that it is subtracted by 2, this is increased by 2, so this is the minimum among all of them. So I just have to ensure that A minus 2 should be greater than equal to 1, because it should be greater than equal to, like, the smaller number should be greater than or equal to the lower value. Similarly with the largest value, this is the largest value, so A plus 2 should be smaller than equal to 6. Okay, so if you just solve out this equation, it will become A is greater than equal to 3 and A should be less than equal to 4. So it actually means that there are two values possible, that is 3. So A is greater than equal to 3, so it is like 3, 4, 5, 6, 7, so on. And A is less than equal to 4, so less than equal to 4. So it means that let's say 3, like 4, 3, 2, and so on. So what are the common of them? 3 and 4. So it means that the 3 and 4 as a starting are actually legit. If you put 3 and 4, then all the numbers will be such that the lower will be between the lower and upper bound, and the upper will also be between lower and upper bound. And the answer will be 2 actually. So as you can see, the answer will be 2 actually for this. Hope you understand the overall logic. Now you just have to implement this only in the overall code. Now how will you do that? Just if you don't think about A, because A we do not care about. We just think about what is the minimum value that is decreasing it. So as you have seen that if you just generalize it, we are just adding all the numbers from left to right. Just adding all the numbers. So it is 0. Then we just add 1. Then 1 I add minus 3. Then for minus 3 I add 4. So these are the numbers that are adding or subtracting to this value. That is the buffer value that is adding or subtracting. Now what you have to do is that you have to just find out the minimum among all the values and maximum among all the values that is actually adding or subtracting here. I hope you get the point. And then among all of them, what you can see here is that whatever is the minimum. Okay. So let's say that I have to just add it like this. A plus of minus 2 is greater than equal to 1, and A plus of plus 2 greater than equal to 1. So because I'm actually plus, like this value is there, either it is minus 2, but it is actually due to sign. I'm just adding it here only because these numbers are adding. Then I will take it to the right hand side. Right hand side means that it's subtracting. So the total value, that this is the lower value, and this is the upper value. So lower value minus the minimum among all of these values, mini, and upper value minus the maxi will give you actually the range over which the numbers can be used. So as you can see, 3 and 4. And then you can easily see that whether this range is actually possible or not. So let's say the minimum will give you 100 and maximum will give you 2. That is not possible because the minimum, the number, like it should be at least 100 and greater than 2. That is not possible. So if you subtract out, what you can say that 4 minus 3 plus 1 will give you the range actually. But if you, but it should be like maximum, it should not be less than 0. So 2 minus 100 will give you like minus 98. Minus 98 numbers in the range. Minus 98 not possible. So I hope you get the point. That is the overall logic for this problem. I'll tell you in the code part now. So what we are doing here is that this is total, maximum and minimum. What we are doing is that we are adding out the numbers that we are told the differences and finding out the minimum and maximum among them, and then the minimum bound and upper lower, like maximum bound. So the minimum bound is lower minus mini and maximum bound is upper minus maxi. So this will actually tell you what I have told you, that I'm taking that on the right hand side, that buffer value. And then we have to just find out that maximum value minus minimum value plus 1. This is the range actually, and it should not be less than 0. It should be like either 0 or greater than 0. So I have to just maximize it with 0, because it can happen that like this is not actually a valid, because the answer can be 0 also, as you can see, if it is not valid. So that's the overall logic for this problem. The code will be in the description, so don't worry. And the last problem is K highest rank items with a price range. So all the problems are not too difficult in this contest, but they're a little bit lengthy and you have to think over them. So what you can see here is that in this problem, K highest rank items with a price range. So we'll go through problem statement. You are given a 0 index 2D integer array grid of size m cross n. Fine. So you're given a grid. So you're also given that the grid consists of the numbers actually, as you can see. 0 represent a wall, you cannot move over that. 1 represent an empty cell that you can freely move around. And all the other positive integers represent the price of an integer in that cell. So there's a price also. Okay, so as you can see that there are different prices that are mentioned here. So you can only move an array like you're like greater than 1. 1 you cannot move on. So you can also move on greater than 1. Okay, then what you can see here is that you can also freely move to any of these cells. If you move on 1 also, it is also not any problem, but you will not get any points. You can only get points on these values. Okay, now it takes one step to travel between the adjacent grid. Okay, that is fine. You are also given an integer array pricing and start. Pricing is low and high, and start is row column. So you are also given a starting block and a pricing range. So pricing range indicates that like the starting row and column defines your starting coordinate, and the pricing range are also interested only in items with the price of range between low and high inclusive. So pricing range actually means that I'm only interested in the items that are having the values that I'm iterating over. The prices should be in the range of low and high. I will only care about that price. You are further given an integer k. You are also given an integer k. Now you are interested in the position of the k highest ranked items, those whose prices are given in the following ranges. So you actually want the k highest ranked items among all of these items, because these items are like in the green, the values that are greater than 1. All those items you want the k highest one, all the k highest one. Now how the rank of these items are defined, that is given you according to these given rules, and as you can see the rank is determined by the first of these criteria that is hit. So anyone, these are criteria are in the order only, and any one of the criteria that is the hit will give you the rank of that. The first criteria is that the distance defined as the length of the shortest block from the start. So if you're moving along in any way, whatever the distance between the block you are and the starting block, it should be the smallest one. If any block that has the smallest one, that is it at a higher rank, then the price is lower. If two items are there and the price, so let's say that they are at the same distance, but the one that is having a lower price among the two prices are giving a higher rating. If they also have a same rating, the same distance, then like the same price and the same distance, then the one that is having a lower row number will be given a higher ranking, and they have the same row number also, then the one that is having a smaller column number will be given a higher ranking. And that's the order. And then you have to like order all of these blocks out, and you have to print out the k highest sorted elements in the sorted manner. Now what you can see here is like whenever I see such type of problems in which I have to find out distances and I'm giving a grid, and I have to like somehow find out the traversal and find out the distances, then one thing which comes to my mind like always, and that is BFS or DFS. But BFS is only matter because we have to find out distances. DFS is very difficult to find out distances actually. BFS is very easy because you can put it in a queue, and in every queue iteration you can increase the distance out. And that's what we're going to do here is, I'll take it and adapt it to the code part so it will make it more clear, because we'll go through the code actually. But this is the overall logic we are using BFS only. We'll go through the code so it will become more clear to you. So what I have done here is that this is a vector, okay, that is used to actually sort out and find out the points, the k points in the end. So this is the vector of vectors, because you have to sort according to 4 criteria. So that is a vector of vectors, so that we can easily sort them out. NNM are the dimensions. This is the visited, because we are iterated over this whole array. We have to also keep in mind that we should not be retaking it, and using a BFS we have to take care of that also. D is a distance, so that we have to keep in track of the distances. Visited of the starting index on which we are starting, that is starting of 0 and 1. The starting index at which we are starting, we have to mark it as 2. Push that into a queue. We are making this queue as the pair of integers, that is the coordinates. And then we're iterating over this while the queue is not empty. Now what we are doing here is, so let's say that we have a queue. Now in that queue, what we are doing here is that for the numbers that we have, what we are doing is that let's say that we have numbers. We have to first update all the distances, because let's say that the array is there. So now we are doing a while loop over all the numbers in the queue, because those of them, all of those will be having the same distances. Okay. Then what we are doing here is that if the grid I'm going to is 0, and 0 means that it is blocked, so we'll just continue out. If the grid I'm going to, as you can see, is greater than 1, because I cannot take that. I can only take a price when it is greater than 1, and the price of that, as you can see, the grid price, that is grid of I, is greater than or equal to price of 0 and less than. So it means that the price on which I'm landing upon is in between the range I'm talking about, that is lower and upper. Then only I will take the block I am on. If this criteria fulfills, because that's the first criteria. If the first criteria fulfill, what I will be going to do is that I will push that particular block with, because I have row criteria, I have to first minimize the distance. So we will first put the distance. Then at the second price is the price, whichever is the smaller price. So price, that is the grade of ij. The third one is the call, like the row, the I, and fourth one is column, so that is j. So I will be pushing this point, like this whole vector that is consisting of all of those criteria in the points vector. And then we will be moving along all the four directions, so left, right, top, bottom, and we will checking that it should not be visited. If it not visited, I will like first make it visited and like push that coordinate into the queue, all the four directions, and then increment by direct and like increment by t. That is how we are doing a BFS. In this whole BFS, what will be done, that I will be appending and taking out the elements that are valid to be visited out. And whenever I land on a block that is valid to be visited out, what I'll do, I'll push out the distance that I've already traveled out, the grid value, the I and j, into a point vector. Now in the end, when I've iterated over the whole grid, it will be in O of n square. Now what, because I've traveled over all the grid points. Now as you can see, m cross n is less than equal to 20/5, so we can easily do that. Now what we have done is, after that we have to sort this all out, because what we have seen is that we have to print out the first k elements that are falling out these categories. So because the elements are inserted in this manner only, they will be sorted according to these criteria only. We just have to sort out. The internal algorithm will sort according to these parameters only, one by one. After sorting them out, we have to print out the coordinates of the values. We have to find out the k blocks that are falling out these parameters. So we will make a vector that is storing out the parameters, and we'll iterate over this whole points vector. So either I will find out the key elements, or this point will stop, point array will stop. So we'll have to ensure that we should be inbound only, and that's what we have to do. And we'll push back the points that is 1 and 2. So this is 0 is the vertical set distance, the second one is the value, the third and fourth are actually the row and column. So we'll be pushing out the row and column into the answer vector and printing out the answer vector. So that is the overall logic that we have done. So there are a lot of parameters in this problem, but if you easily understand what's the problem statement, it is very intuitive, like it is not too difficult, because it uses a certain logic only, BFS only, nothing more complicated, but it has just tried to add more features, more parameters, and that's what you have to learn, that how to append, how to think over and juggle between a lot of parameters. Even the problem is very simple. That is the overall logic and code for all the three problems. Thank you for watching this video till the end. If you still have an doubt, you can mention down. I'll see you next one. Till, like, keep coding, and bye.